some features and tools that can be used to manage the Azure environment. We'll also discuss the resources available for ensuring compliance with corporate or regulatory requirements. In this session, we will cover 3 different lessons. First, we will focus on governance and compliance in Azure. Next, we will discuss various deployment tools for Azure management. And in the third lesson, we will explore different monitoring solutions. In the first lesson, we will delve into Azure governance and compliance. By the end of this lesson, you will be able to describe the purpose of Microsoft Purview, explain Azure policies and resource logs, and understand the role of the Service Trust Portal. Let's begin with Microsoft Purview. Microsoft Purview is a family of data governance, risk, and compliance solutions that can help your organization govern, protect, and manage your entire data estate. It combines the former Azure Purview and Microsoft 365 compliance solution and services together into a single brand. The Microsoft Purview helps you gain visibility into assets across your entire data estate and enables easy access to all your data, security, and risk solutions. Moreover, Microsoft Purview manages sensitive data across clouds, apps, and endpoints. It empowers your organization to govern, protect, and manage data in new comprehensive ways. Microsoft Purview includes unified data governance solutions that help you manage data services across your on-premises, multi-cloud, and software as a service estate. That includes Azure Storage Services, Power BI, databases like SQL or Hive, file services like Amazon S3, and many more. Access policies in Microsoft Purview enable you to manage access to different data systems across your entire data estate. Moving on to another vital component, we have Azure Policy. This service in Azure allows you to create and assign policies for resources control and auditing, as well as management. These policies ensure compliance with various resource configuration rules, ensuring adherence to corporate standards. Azure Policy enables you to define individual policies or sets of related policies called initiatives. Azure Policy assesses resources and identifies those that do not comply with the defined policies. It can also prevent the creation of non-compliant resources. Azure policies can be set at each level, allowing you to tailor policies to specific resources, resource groups, subscriptions, etc. Additionally, Azure policies can be inherited. So when you set a policy at a higher level, it automatically applies to all child groups. For example, if you set an Azure policy at the resource group level, all resources created in that resource group will automatically receive the same policy. Now, let's delve into the concept of resource logs. These logs play a crucial role in preventing accidental deletion or modification of resources. Just as you might have accidentally deleted a document and regretted it, resource logs help you avoid such incidents. Even with role-based access control, Azure RBAC, policies in place, there is a risk that users with the appropriate access level may occasionally delete critical cloud resources. Resource log prevents deletion or update of resources depending on the type of log. Resource logs can be applied to individual resources, resource groups, or even entire subscriptions. They can also be inherited. Meaning you place a resource log on a resource group, it applies to all resources in that group. There are two types of resource locks. One prevents user from deleting, while the other restricts users from modifying or deleting a resource. So delete lock means that authorized user can read and modify the resource, but they cannot delete it. Read-only means that authorized user can read the resource but cannot delete or update it. To better understand resource locks, let's take a look at how they can be configured in the portal. Welcome back to the portal. In this demo, we'll see how we can create locks. Locks can be created to different resources, virtual machines or storage accounts, for example. And we can use it to show you how. For it, I will select the storage account that we created together, demo control with Alexandra, and I will scroll my left side menu to see different settings inside. And in my side of my settings menu, I have locks. So I will select locks and I will add a lock that I will call don't modify. I have two different types of lock, read-only. It means that I can just view the information inside of my storage account and I can't modify my storage account. And we have delete lock, that it means that I can modify the information inside of my storage account, but I can't delete it. We select read-only lock and we create it. Let's try to delete our storage account or modify it. If we'll try to modify or delete, we will have a message saying that we can't delete because we have a lock. Let's try. Confirm delete. And here we have failed to delete storage account because we have a lock. Please remove the lock and try again. So we can't delete because of our lock. And again, if we come back and we delete our lock and we will try to delete, let's refresh to see it. Now, if I delete it and I come back to review and I try to delete my resources by copying the name, delete, confirm delete, and here we have deleting storage account. So our lock was removed and I achieved to delete resources that I wanted. I hope you enjoyed this demo. Let's come back to our presentation. I hope you enjoyed the demo. Let's discover together the Microsoft Service Trust Portal. It provides various materials, tools, and other resources on how Microsoft Cloud Services protect your data, as well as how to manage cloud data security and compliance in your organization. The Service Trust Portal is a publicly accessible website by Microsoft Corporation to publish audit reports and other information related to compliance requirements concerning Microsoft Cloud services. The Service Trust Portal users can download audit reports created by external auditors and access analytical information from Microsoft technical documentation, which contains details on how Microsoft Cloud Services safeguard your data and manage cloud data security and compliance in your organization. To access some resources on the Service Trust Portal, authentication verified user need to sign in with their Microsoft Cloud Service account, review and accept the Microsoft Compliance Materials Non-Disclosure Agreement. Additionally, on this portal you can use My Library feature to add documents and resources, allowing you to access documents related to you in one place and receive notifications when they are updated. We are moving forward to the second lesson in this session. In this lesson, we'll get familiar with the features, tools for managing, and how to put Azure resources into action. We'll dig into what the Azure portal can do, explore Cloud Shell's capabilities, and understand how to use PowerShell and CLI. Additionally, we will learn about Azure Resource Manager and cover Bicep, a useful tool for managing resources. You'll also discover Azure services that make handling both on-premises and multi-cloud setup easier. We will look at Azure Arc to manage Azure's power beyond its usual reach, giving you more control and flexibility. To make the most of Azure capabilities, you will need a reliable way to interact with Azure environments, management groups, subscriptions, resource groups, resources, etc. Azure provides a range of tools for environment management, including Azure Portal, Azure PowerShell, and Command Line Interface CLI. Now, let's explore how these tools integrate seamlessly within the Azure environment. The Azure Portal ensures resilience and constant availability, with presence in each Azure data center. This configuration makes the Azure Portal resilient to individual data center failures and helps avoid network latency due to proximity to users. The Azure Portal is continuously updated and doesn't go offline for maintenance. Azure Cloud Shell is a browser-based shell tool that allows you to create, configure, and administer Azure resources using the shell. Azure Cloud Shell supports both Azure PowerShell and Azure CLI, which is a bash shell. Azure Cloud Shell doesn't require local installation or setup. It authenticates using Azure credentials, so it already knows who you are and what permissions you have upon login. Azure PowerShell is the shell that enables developers, DevOps specialists, and IT professionals to execute command called commandlets. These commands invoke the Azure REST API to perform management tasks in Azure. The Azure CLI has the same functionality as Azure PowerShell, but with commands written in bash. Azure CLI provides same benefits of handling discrete tasks or orchestrating complex operations with code. It can also be installed on Windows, Linux, and Mac platforms, as well as accessed via Azure Cloud Shell. Since Azure PowerShell and Azure CLI based on bash offer similar capabilities and access procedure, I advise using the one you're most familiar with. And don't worry, for passing the AZ900 exam, you don't need to know how to write these commands. Transitioning from the essential tools using to interact with Azure environments, let's now delve into the underlying structure that ensures seamless integration and consistent management. Azure Resource Manager, ARM, is a deployment and management service for Azure. It provides a level of control to create, update, and delete resources in your Azure account. Every time you perform any action with Azure resources, ARM is used. When a user submits a request from any Azure tool or API, it is directed to ARM. ARM performs authentication and authorization checks on the request. It then forwards the request to the appropriate Azure service that takes the request action. It then forwards the request to the appropriate Azure service that takes the requested action. Since all requests are processed through a single API, results and capabilities remain consistent across different tools. The concept of infrastructure as a code in Azure transforms resources management by using code for provisioning and configuration. Infrastructure as a code, or IAC, involves defining infrastructure through code, scripts, replacing manual setups. This consistently minimizes errors and ensures reproducibility. IAC fosters collaboration via version controls and shared scripts, promoting teamwork and consistent configurations. Scalability becomes effortless. Code-based replication avoids manual duplication complexities. Implementing IAC means version controlling code, testing scripts, and using Azure's tools for verification. Infrastructure as a code empowers efficient Azure resource management through automation, consistency, and collaboration. Azure Resource Manager integrates seamlessly with IAC through ARM templates, JSON files that define and deploy resource accurately. So ARM templates are an example of infrastructure as a code in action. With ARM templates, you can describe the resources you want to use in a declarative JSON format. The ARM template deployment validates the deployment code before any execution, ensuring that resources are curated and connected correctly. The template then manages the parallel creation of these resources. For instance, if you need 50 instances of the same resource, all 50 instances are created simultaneously. Developers, DevOps specialists, or IT professionals only need to define the desired state and configurations of each resource in Azure Resource Manager template. And the template takes care of the rest. ARM templates can even run PowerShell and CLI scripts before or after resource configuration. They enable the declarative creation and deployment of the entire Azure infrastructure, including virtual machines, networking infrastructure, storage systems, and other necessary resources. You can write ARM templates two different ways, by using JSON and by using Bicep. Bicep uses a declarative syntax that you treat like application code. Treating your infrastructure as a code enables you to track changes to your infrastructure requirements and makes your deployment more consistent and repeatable. Bicep is intended to be easy to understand and straightforward to learn, regardless of your experience with other programming languages. All resource types, API versions, and properties are valid in Bicep templates. If you have previously looked into using JSON templates, you will notice that Bicep simplifies the template creation experience. It provides a similar syntax for writing templates. You can reference parameters and variables directly without using complicated functions. You can reference the properties of a resource directly by using its symbolic name instead of complex reference statements. In most situations, Bicep automatically detects dependencies between your resources. This process removes some of the work involved in template authoring. You can see on this slide an example of how to deploy a storage account using Bicep. If we examine the JSON code, we will notice that the code required to deploy a storage account will be twice as long as the equivalent in Bicep. For comparison, let's take a look at this JSON code on the next two slides. As you can observe, it takes 2 slides to demonstrate the same task in JSON, which also appears more intricate compared to Bicep. Managing hybrid and multi-cloud environments can quickly become complex. Azure offers multiple tools for provisioning, configuring, and monitoring Azure resources. But what about on-premises resources in hybrid configurations or cloud resources in multi-cloud setups? Azure Arc. Azure Arc allows extending Azure governance and monitoring to hybrid and multi-cloud configurations. The Azure Arc service simplifies management and administration by providing a unified management platform for multiple clouds and on-premises environments. Azure Arc enables projecting existing non-Azure and/or on-premises resources into Azure Resource Manager. This means you can manage virtual machines, Kubernetes cluster, and databases as if they were running in Azure. You can utilize familiar Azure management services and capabilities regardless of where the resources are located. Additionally, Azure Arc offers a cohesive experience by allowing you to view your Azure Arc-enabled resources uniformly. Whether you prefer the Azure Portal, the Azure CLI, Azure PowerShell, or Azure REST API, Azure Arc provides a unified approach to managing your diverse resources. This simplification enhances your operational efficiency and control across complex environments. And finally, we move to our last lesson in this session, where we will discuss monitoring. Azure Advisor evaluates Azure resources and provides recommendations to enhance reliability, security, performance, efficiency, and cost savings. Azure Advisor was designed to save your time on cloud optimization. This recommendation services includes proposed actions that you can take immediately, defer, or dismiss. You can access recommendations through the Azure portal or via the API. Additionally, you can configure notifications to alert you about new recommendations becoming available. With a solid grasp of how Azure Advisor enhances resources management, let's pivot to another indispensable tool, Azure Service Health. Azure Service Health helps monitor your Azure resources, both individual deployed resources and overall Azure status. Azure Service Health achieves this through a combination of three different Azure services. First, Azure Status. Azure Status provides a broad view of Azure's global health status. It informs you about service outages in Azure through the Azure Status page. This page offers a global perspective on the operational status of all Azure services across all Azure regions, making it a valuable guide for incidents with wide-ranging consequences. Secondly, Service Health. Service Health offers a narrower view of services and Azure regions that you use. It's the best tool to find information about issues affecting the functionality of services, planned maintenance, and optimization recommendations for your solutions. You can even configure Service Health alerts to receive notification about service issues, planned maintenance, and other changes that may impact your used Azure services and regions. Thirdly, Resource Health is a specialized view of your actual Azure resources. The service provides information about the operational status of individual cloud resources, such as specific virtual machine instance. The combined forces of Azure Service Health and Azure Monitor enable you to set up alerts that notify you of shifts in the availability of your cloud resources. Speaking of Azure Monitor, you might be wondering what exactly is Azure Monitor. Azure Monitor is a platform for collecting data about resources, analyzing the data, visualizing information, and even taking actions based on the results. Azure Monitor can track Azure resources, on-premises resources, and even multi-cloud resources such as the virtual machines hosted by other cloud service providers. You can set up alerts to monitor logs and trigger specific log events, or configure them to track metrics and trigger when certain values are crossed. For example, you can set up an alert based on metric to notify you when the CPU load on a virtual machine exceeds 80%. Alert rules based on metrics provide near real-time notifications based on numerical values, while rules based on logs support complex data processing logic from multiple sources. Azure Monitor alerts use actions group to customize who needs to be notified and what actions should be taken. An action group is simply a collection of notification and action settings that you associate with one or more alerts. Action groups are used in Azure Monitor, Azure Service Health, and Azure Advisor to send notification when alerts are triggered. With that, we conclude our sixth session where we covered management and compliance, resource management, and monitoring in Azure. Thank you for participating in our training. Let's recap everything we have covered together in two parts of our learning journey. In the first part, we started with the first session and learned about the fundamental principle of cloud technologies. We explored different cloud deployment models and discussed the differences between capital and operational expenditure. Then we described various benefits of cloud services and discussed the 3 types of cloud services: IaaS, PaaS, and SaaS. We finished the first session with the concept of shared responsibility. In the second session, we delved into different architectural components: regions, availability zones, subscriptions, and resource groups. We also looked at different compute options such as virtual machines, containers, and virtual desktops, and compared them. Towards the end of our second session, we talked about application deployment. In the third session, we explored Azure Virtual Networks, Azure Virtual Subnets, Azure DNS, VPN, and Express Route. Moving on to the second part, in the fourth session, we covered storage accounts and compared various redundancy options. Then, we learned about storage services such as containers, disks, and files. Finally, we defined migrations options, as well as file transfer options, including Easy Copy, Azure Storage Explorer, and Azure File Sync. In fifth session, we described directory services in Azure, including Microsoft Entra ID and Microsoft Entra IDDS. We discussed authentication in Azure, including single sign-on, SSO, and multi-factor authentication, MFA. Additionally, we talked about external identities and guest access in Azure. We covered concepts such as conditional access in Microsoft Entra ID, Azure Role-Based Access Control, RBAC, the Zero Trust concept, and the Defense in Depth model. We conclude the fifth session by describing Microsoft Defender for Cloud and various cost management solutions. Finally, in our last sixth session, we learned about management, compliance, and the Service Trust Portal. We explored resource deployment tools such as Portal, PowerShell, CLI, and Cloud Shell. We learned about Azure Arc and Azure Resource Manager capabilities. And we finish our training by describing monitoring tools such as Azure Advisor, Azure Service Health, and Azure Monitor. After our enriching training, I have no doubt that you will successfully pass the exam. And remember, all the materials we covered during our learning days are also available on the Microsoft Learn website. Happy learning and see you soon!